Chapter 3.2, Rolle's Theorem and the Mean Value Theorem, Day 2. Just a reminder, there are 4 existence theorems. And these theorems prove that stuff is there, but doesn't actually find it. They are the intermediate value theorem, the extreme value theorem, Rolle's theorem, and the mean value theorem. In order to use the extreme value theorem, our function is continuous. Continuous on a closed interval and between two values. And it proves that there's something, a y value between two x values. The extreme value theorem, in order to use it, is continuous on a closed interval. And that says that there is a max and a min on that closed interval. Rolle's theorem, there's 3 things that must be true. It is continuous on the closed interval a to b, differentiable on the open interval a to b, f of a equals f of b, and it says that somewhere the derivative is 0 between a and b. And then the mean value theorem must be continuous on the closed interval, differentiable on the open, and somewhere in that interval, the instantaneous rate of change equals the average rate of change for the interval. Determine whether Rolle's theorem can be applied. If it can be applied, find the values of f prime of c where it's equal to 0. So first off, this is a sine function, so we know it's continuous and differentiable on all real numbers, so it's definitely continuous and differentiable from 0 to 2 pi. We need to then find f of 0 and f of 2 pi. We see that both of them are 0, so Rolle's theorem applies. To use Rolle's theorem, we need to find the derivative. Derivative of sine is cosine, set that equal to 0. Where does cosine equal 0 between 0 and 2 pi? Well, that would be pi over 2 and 3 pi over 2. Those are the values where f prime of c equals 0. And it could be more than 1, but it's guaranteed to be at least 1. Apply the mean value theorem. All right? Mean value theorem, first off, is this continuous? Well, sine is continuous and differentiable, just like it was in the last problem. So we can find the average rate of change, f of pi minus f of 0 over pi minus 0. Sine of pi is 0 minus 0 over pi. The average rate of change is 0, so we're looking for where the derivative equals 0. All right, we'll start by taking the derivative, which is sine. Sorry, the derivative of sine, which is cosine. And cosine of x equals 0 between 0 and pi at pi over 2. So the average rate of change equals 0 at least once between 0 and pi, and it happens to be at pi over 2. All right, here is a very famous AP exam problem from 2007. Out of 9 points, students averaged half a point. And all it's saying is, basically, does stuff exist? All right, so read through it. The functions f and g are differentiable for all real numbers, and g is strictly increasing. Okay, differentiability implies continuity, so f and g are also continuous for all real numbers. The table gives values of the functions and their first derivative at selected values of x. The function h is given by h of x equals f of g of x minus 6. Explain why there must be a value r between 1 and 3 such that h of r equals negative 5. Well, this is an existence theorem. It's saying, why does this exist? Explain why there must be this number. All right? Well, here it's saying h of r equals negative 5. That implies kind of an intermediate value theorem. We want to show that h of 1 and h of 3 surround negative 5. All right, so we're going to find h of 1, f of g of 1 minus 6. G of 1, according to the table, is 2. So that's f of 2 minus 6. And f of 2 is 9. Minus 6 is 3. So h of 1 equals 3. Let's find h of 3. That would be f of g of 3 minus 6. G of 3 is 4, so that's f of 4 minus 6. F of 4 is negative 1. Negative 1 minus 6 is negative 7. So because h of 1 and h of 3 surround negative 5 by the intermediate value theorem, there is an r. There is an r such that one is less than r is less than 3, and h of r equals negative 5. All right? So by the intermediate value theorem, we surrounded the negative 5. So because we surrounded the negative 5 with the 1 and 3, it has to exist somewhere in the h's. And finally, another existence theorem problem. And I do that all the time. Let's group it so it can't get away from me. All right, functions g and f, yeah, I read that before. Explain why there must be a value of c between 1 and 3 such that h prime of c equals negative 5. Why must the instantaneous rate of change be negative 5? What theorem guarantees an instantaneous rate of change? Well, the mean value theorem. So what we want to do is we want to look at 1 and 3 and find the average rate of change between 1 and 3. So that means h of 3 minus h of 1 divided by 3 minus 1. And then if we look back, we already found those. H of 3 is negative 7. H of 1 equals 3. So because the average rate of change equals negative 5, and the function is continuous and differentiable, somewhere h prime of c must equal negative 5. Because h is continuous and differentiable, h prime of c equals h of 3 minus h of 1 over 3 minus 1, which is negative 5. And that's the mean value theorem. So in conclusion, the four theorems. The intermediate value theorem, which states a value exists between two values. The condition to use it, it must be continuous. The extreme value theorem, which says there is a max and a min, and again, this must be continuous on a closed interval. 3, Rolle's theorem, which states there is a slope of a horizontal line, of a tangent line that's horizontal between two values when it's continuous and differentiable and the endpoints are equal. And the mean value theorem, which says on a continuous function and a differentiable function, somewhere the average rate of change equals the instantaneous rate of change.